All right, good afternoon, everyone. Welcome to our series of conversations on complexity. It is surely an honor to introduce Professor Alex Sandy Pentland, who is a visionary in data science, artificial intelligence, and the study of human behavior. Sandy is a fellow at Stanford's Institute for Human-Centered AI and the Toshiba professor at MIT. He directs MIT's Connection Science Initiative and was instrumental in founding both the MIT Media Lab and Media Lab Asia. He is an advisor to the Innovation Laboratory of the Abu Dhabi Sovereign Wealth Fund. Sandy is one of the most cited computational scientists in the world. He was named by Forbes as one of the 7 most powerful data scientists, alongside the founders of Google. His pioneering work spans computational social science, organizational dynamics, and wearable computing, including key contributions to innovations like Google Glass. In addition to his academic leadership, Sandy has co-founded many ventures that have positively impacted billions of people, particularly in underserved regions of the world. He has advised global institutions, including the United Nations, Google, and Nissan. On a personal note, I've had the privilege of collaborating with Sandy over the years. His intellectual influence is far-reaching, often channeled through the brilliant students and postdocs he mentors. Today, Sandy will again introduce some new and exciting ideas, offering a fresh perspective on artificial intelligence. Rather than designing AI to mimic human cognition, he is proposing and advocating building systems that complement human intelligence, unlocking more effective and synergistic outcomes of AI and people. He will share compelling examples from finance, science, healthcare, intellectual property, and public policy. Please join me in welcoming Sandy.
Thank you very much. Thank you very much. Glad to be here. So my idea is sort of a simple one, which is that instead of just designing AI as if humans didn't exist, essentially it's a sort of a mimicry of people in some way. You would like to maintain agency of people. You like a human culture. And so the question is can you design AI and other sort of related IT tools to complement human intelligence and human culture rather than shift it or constrain it. And I think a lot of people would agree with that, but it's not obvious how to go forward unless you understand it some mathematical detail about how humans think. What it is the computational theory of how we were put together to be able to survive. And so that's what I'm going to talk about today. And then I'm going to give you a couple of examples where thinking in this new way gives us enormous leverage for advance. So let's see if we can share the screen here. Where is it? There it is. Okay, good. So one more click. I think that will do it. Okay, well, good enough. So AI for humans, there we are. So the fundamental thing is that, let's see, this is having some difficulties, apologies. There we are, a little better. People are not very good at reasoning, at least since the time of the Greeks and certainly since the Enlightenment. We've had this sort of almost sort of meta theory about how we think and that's that we're rational individuals, that we're thinking things through. And that's the main thing that, for instance, education is focused on. And it's the thing that we celebrate. But, the reason we go to school for 20 years to learn to reason is we're not very good at it. I just thought I'd give you some examples. So I have a book that talks about the 16 common errors in syllogisms. So this is crazy. 3 lines of 3 sentences, right? All X or Y, that sort of thing. And in tests of people who are average educated people, typically 2/3 have errors. That's crazy. After all that education, we're still basically incompetent. Um, just to sort of illustrate that, 25% of Americans think that the sun goes around the earth. So it's only been 500 years. Eventually we'll get there. But here's one that probably is should cause reflection among the crew that's listening now, which is Pew did a big survey of people around the world on climate change. And they found 85% of the world population think that governments should do more about climate change. So what's this business about climate denial? I mean, look, 85% of the world thinks we're on board and we've got to act. That's what we ought to be talking about. I mean, compare that to the 25%. Anyway, you can buy into what I just said there or not. It's up to you. But the point is, we're not individual rational thinkers, right? So what is it that we're doing? And this is what I think we're doing. So we're doing social foraging. So what that is you learn from others, you see what other people do and how it worked out. They eat the blueberries, they get sick, they eat the red berries, all good. You then compare those sorts of things that you can learn from other people with your own personal experience, and then choose a number of things from the posteriors, from the combination of those two. And a good example of this for networks where individuals can be somewhat private, where they can have adversaries. This is a rather significant generalization of game theory, is the reference there. The interesting thing is that it's mathematically optimal in the sense of being minimum regret. You're making the best decisions out of the set that you have of possibilities that you have, given the data that you have. That sounds like a pretty good policy. And it does an excellent job of describing things like foraging in bees and even great apes. And interestingly, people. And so, for instance, we did a large experiment, this Josh Tenenbaum, Griffiths, et cetera, that appeared in Cognition, which is sort of the leading cognitive science journal in the world. And basically, this is sort of a sketch of what people do. Let me just make sure that this thing is out of the way. There we go. So what people do is they collect examples, add that to their own experience, and then select the likelihood off of that. Now, what's interesting is that people don't do this in just a Bayesian framework. They don't do it necessarily the way you think. A good way to understand that is think about some of the classic experiments, like, for instance, the Milgram experiments, where you'd be brought into a room and there'd be a couple of guys in white coats, and your job was to shock some person you couldn't see. And they started complaining about their heart, and the guys in the white coats said, "Oh yeah, just turn up the voltage," right? And most people did. The part of that experiment that was interesting was if there was even one person in the white coat who said, "Don't do it," most people wouldn't. In other words, people were taking the things that other people were recommending, listening to experts, etc. But if there was some sort of alternatives in those expert opinions, they would leap on that. It's not a question of counting votes or anything like that. So that's really interesting. And what this paper here shows is that in the area of finance, so this is personal finance, people investing money, that while people have lots of defects as individuals, the collective is actually very close to optimum, mathematically optimum, by using this sort of social sampling of what are the possibilities, considering them from a personal perspective, and then choosing. One of the things that's important in thinking about that is that we don't always pick things that are reliably good, because there's a lot of options. And this is known as the exploitation dilemma. You can pick the choices that always worked for you, but it's also good to allocate some energy, some investment to things you don't know, because they might be even better. And this is particularly important in an uncertain and unstable world. If you've got a non-stationary world, you have to continually explore. And that's what people do. So sometimes they do things that don't seem rational at all, but they're part of this foraging behavior so that when things begin to change, they have some hope of surviving. You're beginning to see this now, for instance, in some of the large language models where they're using this sort of sampling thing to be able to very efficiently do this sort of collaborative sampling of the data that they have trained on. So people use this pretty well. So looking at individual trading on a platform called eToro, so the average person has about $10,000 they're investing. And if you see down the bottom, most people only look at a couple of strategies. They each time each week they consider maybe one, maybe two more. And you can use this social sampling mechanism to be able to help them consider more orthogonal, uncorrelated strategies, and suddenly they do much better. So this is just illustrating that the mathematics actually works in the real world. And these are something like a couple 100,000 people from all over the world that are participating in this experiment. So you might say, well, of course, experts would be different. Well, actually, experts aren't different. They use the social sampling also, but they use it in a more nuanced way. So, for instance, we got about 2,000 finance experts from around the world, and we gave them information about various sorts of possible commodity trades, and we asked them for predictions. And then we showed them what the other people did. And some of them really responded to their social context. In others, they were social samplers. Other people were just strictly quantitative. And what was interesting is the quantitative people, the logical reasoners, actually did do a little bit better, but they had a much higher risk profile. And that means that their Sharpe ratio, their overall return, was lower. The people that were social made fewer bad mistakes at the price of a little bit of return. But if you were going to repeatedly invest your money, you want to go with the more social people. And there's the paper about this. And you can sort of read about it and sort of figure out what you want to do yourself. Myself, I'm going to be down there where in the more social category so that I don't make those serious mistakes. So one final bit is arguing that this social sort of sampling theory is a good one, is this that appeared in PNAS, some of my recent students. And what we looked at is we looked at having people estimate essentially the slope or the regression coefficients for various sorts of synthetic data. It's an artificial problem, one without a lot of prior expertise in it. But what we could do is we could have groups of people. So for instance, we looked at individuals in groups that didn't know each other. And what we were just doing was the wisdom of the crowd aggregation. And what you see is you see a performance curve in terms of error and standard deviation. But what's interesting is if you allow these same people to pick who they're going to have in their group by similar answers, by informative guesses that the other people make. So in other words, they say, who am I going to pay attention to? They do much, much better. And in fact, they do strictly better, which is really interesting. Sorry, those are, I did that wrong. If you look at the group where they get to know each other, so they're not just random people, they do strictly better. If you get them to choose the people, they do even better. And so small groups, groups of 6 in this case, where they get to pick who their team members are in terms of performance criteria and information, do strictly better than the other sorts of teams. So again, that's this sort of social sampling and illustrating to you that this picking the strategies other people use and learning from that can give you reliably better performance. One thing to mention about this is in this experiments, we also did things where there were discontinuous changes. And what you'd see is you'd see the criteria, the parameters of the experiment would change without telling the participants. And what would happen is they would rewire who they listened to very quickly and then resume high levels of performance. So this notion of forming networks to learn from is a dynamic one, and that allows them to maintain high performance even in non-stationary environments like the one we all live in. Okay, well, so that's the background. Um, Let me just show you a real example for this. So this is a recent paper that's under review. I'll show you the names of the authors and so forth. It's a multi-person thing. And this is the web of science. So one of the things that we might want to do with AI is improve science, make it much more directed, much more context sensitive, I think is the way to say it, okay? I've just showed you that what people do in making decisions is they use social context, what other people are saying, to be able to make their own decisions. And scientists do this too. And the context that we get is citations mostly. Citations and of course, similar sorts of incentives and things like that. And if you look at the web of science, so these are all the citations. This is the context in which, for instance, over in the right, biotechnology and toxicology happens, and on the left, you see brain studies and nursing, and you see they don't talk to each other at all. But you do see that microbiology talks to biotechnology, that toxicology talks to microbiology a little bit, but there are these big gaps in the web of science, which means that the networks that people are learning from have gaps. And the question might be, what do you do to fill in the gaps? Because it's the truth that the most high impact papers tend to be one that fit between other existing areas. They fill in the gaps. And so what the people along the bottom here, a couple of very talented students who are now faculty, Sandra Lirum, Esteban Moro, myself, and YY An as sort of the supervisor folks here, helped put together a model that put into place this notion of social sampling and context. So we introduced a neighborhood function. Apologies for the little bit of blurriness here, which said, well, people pay attention to things that are similar but not too dissimilar. Okay, and they pay attention to things that have more citation, not less citation. So to look at this little piece of this web of science that's off on the left, you see there are some gaps. Now, if the gap were really huge, that wouldn't be useful because those communities don't share language, they don't know what to say to each other. But if the gap is within the sort of semantic neighborhood, then they would reinforce each other. So what happened, what we did is we took this and we used a word-to-vec style embedding, so a deep neural net embedding. And what you're seeing here is a 2D projection of that, okay? So it is an AI model being used in this case to predict potentially fruitful gaps in the web of science by looking at the context. Note that we have nothing in here about context. We don't know anything about the facts of the matter. We just know where the breakthroughs will happen. So we know where to look. We don't know what we're going to find there that actually works. In other words, we can build tools now that help scientists direct their attention to potentially valuable areas. Does that work? Well, here's the sort of science of science results that are out there. It's a heavily studied area. Everybody knows that if you're famous, people pay more attention to your papers. And so if you look over the next 20 years, You see that a famous person's papers will tend to have a, a, a good chance of being in the top 25%, but an AUC roughly of only 0.4. If you look at the nonlinear dynamics, so the preferential attachment, you can do a little better than that. But if you use this community model, which is just a social foraging model, right? You can essentially almost double the accuracy of what you're doing. And that is pretty amazing. This works even for the top 10% of papers and so forth. And notice that it's over 20-year time zone, time horizon. So you can actually predict what are the things that are most likely to be most interesting, but you can predict where they are, but not what they are. So that's pretty interesting. What's even more interesting is this works with law and patents. Both law and patents have citation structures, very different generation functions. They're not the same sort of logic, all the sorts of things we're taught about how to behave, to think things through, don't apply in anything like the same way, particularly law, which is just judges citing prior work in order to make their decisions. And the judges are randomly assigned, and it covers the entire space of complaints and so forth. But yet the same mechanisms apply with similar sorts of accuracies. Patents decay a little faster than science. Uh, Law is pretty persistent. It's surprising. Uh, and let's see, we had the paper here. Let me just go back. So there's the people, search on that. It's in review, it's on archive. Okay, so we've talked about being able to use this social sampling, this context mechanism, to be able to predict financial things, to be, with investment. We've talked about it to be able to do patents, to be able to do science and law. You can also imagine more broad understanding of the world. So this is something that comes from the Prime Minister of Singapore's strategy group. And what they're thinking about is how do we take all the data that we have from things like value chains, military, crypto, trading, and figure out what the causal structure is. Now, if you sort of stand back and you think about how we govern ourselves in any country, we're terrible. It's all heuristic. Well, Joe did this back in 1860 and it worked pretty well, so we're going to do it again. That is not science. What you could do, though, is take all these data planes where you don't know the causal connections, and you can begin to ask, are there connections there that have the right sort of structure to potentially be causal? And what you do is you use the model that I just talked about, and you make a realization. So you think, well, people are not independent when they take actions of various sorts, when they make connections. And let me go back just one more to sort of point out that actions on one plane here may be done by the same person who also acts on another plane. People are often the conduit of shocks between these different feature planes, right? Between value chain and military or funding, etc. And what you get to see in the data is one plane, but you don't get to see what's going on with the people. But now we have a little bit of a theory about what people are doing, and we can begin to sort of turn that upside down in a different way to sort of understand. So when people are doing things together, or if they're doing things in different domains for that matter, what you see is you see a pattern of interaction. So I call that causal filtering. Maybe isn't the best name, but the idea is that it's not causal analysis, but it's a precursor where you can search through literally billions of possible connections very quickly to find things that have either mutual information or correlation. And those correlations and causal or mutual information can be caused by patterns of interaction, right? If every time something happens, you send me a message, and then I respond to that, send you something back. That's a pattern of interaction that happens only between people that typically know each other. Sometimes there's some noise in there, obviously, but the common thing is that's a very good filter for looking at causal connections. And the same is true for members of a group. If a group is working together and you can't see them, let's say, what you will see is the people that work with the group have similar patterns of action. Okay, because when the group does something, the people who are working with the group have to respond. And let me just go back one other thing. It's also not the sort of thing that is easy to fake or hide, because typically actions you take are to a timetable. If you're trading, you have to get the money in the right place at the right time. If you're building something, all the resources have to come together at the right time. So there's external constraints that cause people to be correlated and have similar related interaction times. And the way we measure this, and this is work with Shahar Soman, who's just became faculty in Israel, is in terms of a burstiness measure. It's just, if I see that you're active at time 1, are you also active at time 2? How many times is there a gap of just 1 between your actions? How many times are there gaps of 2, of 4, of 6? So it's characterizing essentially a type of, it's a type of entropy measure, not formal entropy, but of your interaction. And two people that interact with some fairly tight constraints will turn out to have very similar types of burstiness pattern. Now you may say, oh, I can think of lots of ways around that. You're wrong. So we're going to look at 3 different things. We're going to look at a person that have a single identity, but many different digital identities on different networks. Can we tell that it's the same human, even though it's activity with different synonymous identities on different domains? Even harder is sort of the generalization of that is you have a particular domain, like finance, and you have a bunch of people who are working together. And you notice they all have black hats now. That's because black hat people tend to do this sort of thing. But we're not looking only at black hats. So when you seek coordination within a group, that tells you something about what that the group is collaborating with each other, and maybe you should look closer to see what it is. So, and then the final thing is a group that's collaborating across many different domains. That's the hardest thing. Now, you might say, well, okay, content filtering and so forth, but what we're dealing with here is we're going to use fully encrypted, fully synonymous domains only. So, and because that's where the world is going. Telegraph, signal, blockchain systems, etc., are all encrypted with synonymous identity. And you'd still like to be able to do these same things. If you can do it there, you can do it in the more general sort of strategy problem. There's the archive paper about it. And the 2 examples I'm going to show you is identity matching across blockchain trading markets. So a profile for each trading market. So there's separate communities on a platform like Ethereum. And what you'd like to do is you'd like to know if they have different identities and they're doing one thing on the left hand and another thing on the right. You'd like to know it's the same person. And you can do that on things like Telegram, which is encrypted, and compare to that thing like Twitter that isn't, but ask, oh, look, it's the same person in various ways. And this is the type of result that you get. So these are AUCs. All of the bars, except for the first one, are large language model, word-to-vec types of things, classical methods of identifying when things are simple, similar. And you see that this burstiness model works really as good as the best, actually slightly better than the best, and in some cases, much better than the best. It's also interesting that this is far more efficient in terms of order of computations. So this is really, you can make it close to linear, whereas the other ones are quite expensive to do. Okay, so that's the simple version. This is the slightly more difficult version. So you have a bunch of people on an encrypted domain, like a blockchain or telegraph, and you want to say, are they actually working together? Even though they have separate names, they do things at different times. And you see that various sort of hacks that people use, common transactions, common neighbors on the network, activity time intersection, don't work nearly as well as the burstiness model, which gives you an AOC that approaches one. That's really pretty spectacular for encrypted data. And this is the hard one, which is people working across many different platforms. And again, you see that the burstiness model on financial workers, for instance, works extraordinarily well. And it works whether, what's interesting is it works better than hashtag similarity. So if you happen to have the content, you can actually do better by looking at the burstiness. And obviously, if you have both hashtag and inner event, you can do both. And there's the paper. It's on archive again. So again, the point with this is trying to acknowledge the fact that people learn from each other, they collaborate with each other to make estimates, to take actions. And what we're doing is we're looking at that foraging activity to be able to identify who's working with who in what places. And you can do this in ways that matter. So for instance, this is looking at all of the social media accounts from from Russia and asking how do they compare to the social media accounts from the government of China. So these are government accounts. They are not all labeled as government accounts, but we know that from things like Interpol and other sorts of technical sources. And what you find is that the People's Republic of China support some of the Russian state outlets, but not all of them. So there's some political division in there, and that won a Best Paper Prize at SPB Brims, and you can look for it. It's online. So I'm going to sort of wrap it up there because I think we have the right time. The point is that we can do is once we realize that what people are foraging rather than doing deductive reasoning, and so this is called abductive reasoning, then we can build tools that help us search better, to find examples that are better, to have better context, without interfering with the central ideas and thought that we have. It's like being sort of more aware of the context or better educated. And that's the way I've been using these AI tools in the examples that I've shown you, where we can accelerate science, we can accelerate technical advances, patents, where we can look at lacunae in law, where we can analyze vastly disparate data to find possible connections, and where we can find the stuff of cybercrime, again, all on encrypted data. So I'm just going to stop there. And I know that was all fast, and I apologize, but hopefully it got it across and is interesting. So we have another 15 minutes, something like that.
Definitely. Can take some questions, right?
Yep.
Yes, certainly.
Let's do it.
I would either drop your question in the chat or raise your hand, and we'll do our best to call on you and in the order, and we'll take as many as we can over the next few minutes.
Somebody doesn't believe anything that comes from NPR. Well, okay.
Yeah. Who has a question? Let me ask. I think the fundamental question, of course, is given that people are coming up with ideas and then comparing them with others, we should have some understanding of both aspects of it, right? And I'm sure that you have common things to say. Why don't you share something about these two different aspects of how people are engaging?
Well, I think that the biggest change, right, is actually this notion of not saying we're going to be doing accenting the deductive as much as we do. It's not that deductive isn't useful, but that really we live in a very highly uncertain and unknown world, and what we're engaged in is a search process. So we want to think about human behavior as a collaborative search process. And a sort of very rigorous mathematical version of that is you have a bunch of multi-armed bandits. So they have a bunch of choices they can make, and they're experimenting and observing to make the best choices that they can. And they have the exploration dilemma, and there's the statistics of trying to figure out which strategies are best to you. But having the view that what we're trying to do is find strategies for survival, strategies for progress, rather than trying to do deductive logic off of things we already know as the primary driver, is a major change. Because what it says is that we need to think about at the level of actions, not facts. It says that we need to acknowledge that we don't know most of the actions that we can take, and we don't know why they work also. So
Mhm.
for instance, how many people know how their cell phone works? About zero in the whole world. I mean, I actually know something about it, and I can tell you, uh, you can know some little area of that device, some level of technology, but you don't know how the whole thing works. And yet we use them all the time because there's a successful strategy. And of course, by understanding more, maybe we can find more things. But the fundamental thing is to be a little bit more modest about what we know and don't know, and think more about sort of being experimental and learning from others. And so AI can help you with um, thought experiments, can help you with finding what others are doing. It can help you collect data across domains, all without actually impinging on the core decision process that a human has.
Let's call Esther. You want to come on off mute and ask your question?
Sure. Thank you. Very briefly. Hi, Sandy.
Kai,
I'm curious how you see this applying to AI and I totally agree with let humans be human, let AI be AI. So what are the implications for AI? What should we do or not do? What are people doing wrong, et cetera?
I think that the reason I'm emphasizing this, we're on a search rather than deduction, is the fundamental thing is not that AI is a problem per se, it's how we use it.
Right.
We often use it just to replace people. And if you think about humans as though we're going to deduce things, so I'm going to ask the AI for an answer, that's a fundamental mistake. If you use the AI the way you use Google to search for stuff, or the way we use, for instance, the IPCC, the climate change body, which runs all these big AI models to figure out what's happening with the climate, um, that's pretty good because it's still humans trying to figure out which things we're going to bet on. And I guess that sounds really simple, but
Okay.
having people realize that you're not after the answer, you're on a search to find out what works is, I think, the core idea.
And then use humans to make the decisions because they're better at figuring out the subtleties that the deductions don't come up with.
Yeah, absolutely. But also, I mean, I, I have a book that's coming out, but the one observation is that in the last about 15,000 years, we've all been around. We've had 400 feet of sea rise. We've had pandemics that wiped out half the human population. I mean, we've had all sorts of stuff, right? And we're still here. There are peculiarities about how we think that evolution has selected for, like, for instance, certain sorts of risk aversion, certain sorts of drives for curiosity that, may really be very important for our survival. They're not just, logic and facts and figuring it out. And I don't think we understand all that subtlety, right? And it's important to maintain that sort of human perspective if only because, it's worked for the last 100 disasters we've had. Not everybody survived, but we're still here, right? And that's, I think, the idea.
Sandy,
Well, I mean, the point is that not everybody survived because the smart ones survived. Anyway, thank you. I look forward to your book.
Okay, thank you.
Let's call
Sandy,
on Kara. Oh, so sorry, Yanir.
yeah, go ahead. Yeah, you go ahead.
Kara posted a question in the chat a while ago. So Kara, if you could come on screen and ask your question.
Okay.
And then we'll move on to George.
I
Thank
cannot get
you.
my camera is not working with my Mac right now.
Don't worry.
But I will say, I'm going back to my question. It basically, fundamentally, I'm just curious to know more how you think this is fitting in the realm of that you're looking at ideas that are in a very complex space, like cutting edge R&D in a scientific domain where I know you had a slide where you're kind of like, well, in some contexts, there are people who know more. There are some domains where that extra knowledge is critical, or else whatever it is that people are coming up with may be irrelevant or, not real.
Sure,
So just
sure.
curious how that applies here, because I come from that technical background and we're looking heavily, how do things change so rapidly? How do we stay at the
Yeah,
forefront?
I don't mean to say that stuff isn't important. It clearly is, right? But I think that it's also important that we not stick only to that. So, I'll give you one or two classic examples, and then something we're doing now, which is pretty amazing. Take ulcers. Everybody believed that ulcers was because you were, drinking too much coffee or something like that. And the guy who said, no, it's a virus, was nearly drummed out of his job. So what he was doing, right, is he was saying, I'm going to get outside of the existing framework and look at it from different points of view. Now, he could have easily been wrong. There's lots of nut jobs in the world, right? But you need to have a mechanism that is much more open to search and new possibilities, and also a mechanism that constantly weeds out hypotheses based on their performance. And medicine does a lot of that, but let me give you an example of something that we did just recently, which, is 100% against the NIH charter, right? It's a fishing trip. So what we did is we took microbiomes from cows, in this case, an animal model, and we just did the normal shotgun RNA thing. And then we did these same sort of statistics that you just saw for science on that. We don't know what organisms are there. We don't know what the mechanism is, but what we observe are biomarkers where there are unusual statistics, that causal filtering thing again, right? Very unusual, that are extremely unlikely to happen by chance. And incidentally, they correspond to methane production. So if you feed the cows, when they show this marker, you should feed them this. When they show that marker, you should feed them that. Reduces methane by 50%. Now that would be about, I think it's 2% of global warming. Not too bad, but that's not the really good part. The good part is you can do it on people, because you're just like doing biomarkers off of, right? And so in the examples we've done, which are limited so far, but we're quickly expanding, we've been able to double the efficacy of medical treatments because we can select the people that will respond best because they show that sort of pattern in their microbiome. And every single thing we've looked at so far, we've been able to do those sorts of things. It's a small set of things, but that's pretty amazing. And that sort of fishing trip that we did, right? We're going to look at stuff and look for things that are unlikely, is pretty much prohibited by NIH charter. Is that no, you have to know your mechanism. We don't. We just know that it works. And what's interesting is we have some of the leading Nobel Prize winners in the area, who have invested their own money in this and are excited about it. So, hey, they've got expertise. They think it's and it's just this attitude of we don't know a lot, right? Let's see if we can find things that are suspiciously unusual and figure out what they're doing. And I don't think we do enough of that. We tend to go for uniformity. We tend to think it's all like, reductionism. And I think that's the main sort of message.
Thank you for that. I'll just say scientific publishing does drive a certain one of those models, and not so anyway.
Absolutely.
Yes, thank
Well,
you.
I showed the thing with the Web of Science. What
Yeah,
people really do is they look for places where they can get a lot of citations. It's an amazing mechanism, right? And there's a field called science of science that shows that people tend to explore more when they're not getting big super hit papers, and the moment they get a hit paper, they stay in the area for a while, so they stop exploring, and then when that runs out, they move on. So they're very much like, rabbits looking for berries or something like that. It's just in this very sophisticated space.
George.
George. Oh, I'm sorry, Yanir. Take it
No.
away.
Okay. I've just scratched the surface of playing with AIs. And the thing that I've seen is that there's no context and no perspective.
Correct.
And that feels for me very, very hollow.
Yeah. No, the model I have of all the current AIs is like, if you asked me a random question and you didn't mind if I BS about it, I could give you some story, almost anything, right? And that's what the AIs are doing. They've just collected all these stories, and if you poke them, they give you a story, right? But there's no context to it. Moreover, they are not, some of the most important context they miss is the context of what other people, other AIs are thinking, saying, doing. They're all sort of isolated. So they're individual storytelling little bots. Yeah. Amazingly powerful what you can do with that, but it's hollow. It's not thinking. So people talk about AGI and all that stuff. No,
Right.
I'm sorry.
I'd also object to Esther Dyson's idea that the smart people are the ones who survive. I'm not necessarily sure that that's real.
Oh, well, no, wait. So what do you mean by the word smart? I would define smart as the ones that survive. Our ideas about smart being schooling and quick response and so forth are not necessarily adaptive for long-term survival.
Robert, you have your hand up.
Yes, the concept of social foraging that was really new to me, and I think it captures something well. And I was just thinking of, in my own personal analysis, that it's something I do, and also with AI tools to go across all of them and kind of forage around and people and things. But I was wondering, if you take or a journalist, for example, or someone that needs to, often will refer to whose side of them, what's the popular view or what's the expert view, as a kind of a tagline. But if you're time constrained, are there ways to actually use the social foraging as a method to to be able to
Yeah.
get some tablet of recommendations without just defaulting to, oh, the experts say this or most people think that?
Yeah. So in the model I showed at the beginning, if you pick opinions that are what you want to do is you have a family of things that you know how to do, your actions, your things that you think make sense. Okay. And what you'd like to do is complement that with things that are different, substantially different, just to be sure that you're covering the space and you have the context correctly, right? And in a sense, that's what Google does. I think this is why Google search has been so compelling over the last 20 years or whatever it is. is that, you always say, oh, I forgot about that, or I didn't know about that. And that function of finding things is absolutely critical. So finding things from experts, that's great. There are so many things in our society that make experts have very similar opinions that you have to be a little skeptical about that. I don't have the veneration for experts that many people do, and partially that's my career. My career is finding when the emperor had no clothes, right, and saying, "Hey, the emperor has no clothes," right, and it happens in every field. I mean, just take the example of physics, which is probably the most developed part of science, right? Because it's been so quantitative, it's so experimental for so long. And if you notice, about 20, 25 years ago, they found out that they were missing about, 90, 80% of all the matter in the world, dark matter, dark energy. It's like, here's this thing that tells these very concrete stories about the beginning of the universe and how things work. And it does work, right? That's how we build things. And then they discovered that they were just talking about the stuff on the edge and not the main process. That's pretty crazy. I mean, it really is. It's a little bit like, back in the 1800, Pasteur saying, hey, wait, it's not just the humors and things like that. There are these little bugs everywhere. And that was like mind blowing for everybody, but very good for us, right? Because now we know how to fight the little bugs that are everywhere.
Thanks.
Thank you.
Robert Brooks, you have a question that you posted. You want to come on?
Well, I posted a whole bunch of stuff, so I'm not really sure which question you're referring to, but I guess the main question is similar maybe to the other Robert, which is, okay, how can we use this, or how can other people use this information, in particular the social foraging type approach or strategy, to improve conditions? I mean, I think ultimately, probably most of us would like to improve conditions and not just be using this for intellectual pursuits. So
Yeah,
you seem to be along that line. So
yeah, I mean, I see two things that are barriers to doing that. Now, this is I spent many years working with Secretary General of the UN to try and come up with answers to what you just said. And the two things are, first of all, you have to have measurements about things. There's so many things we do and we don't really pay attention to whether they work. We just tell stories. And this is a lot of what, gets politicians reelected, but everybody does this. We don't actually treat all the actions we do as experiments, right? We say, oh, this is the right thing to do, sort of logical, reason it out, and then do it. And then we have this weird habit of walking away. So like, for instance, if you look at philanthropies, only something like 4% of them ask the question of, is this philanthropy of donors, only about 4% ask, is this philanthropy actually effective? And only about 2% follow that up with a post-mortem asking what was the effect of their donation. That's crazy. Same thing with much of the government. So more data is scary to people. We need to have better methods of evaluating things. But equally important is the idea that you need to have lots of experiments happening, lots of very diverse experiments. And, there's a famous thing about the US states being laboratories of experimentation, but that's not nearly as true as it was 100, 200 years ago, because all of our IT systems make uniformity. That means we only try one thing at a time across the whole country, which is crazy. You want to try different things, see which things are good, evaluate them short-term, long-term. It's just this attitude that, no, we don't know what's the right thing to do, and we don't know what's important, and we have to continually search for that and evaluate. That's, I think, sort of the biggest change here.
So
I see that it's 11:59,
11,
so
yeah.
probably I should say
We're-
goodbye to folks
yeah.
here.
Thank you
But,
very much,
Okay.
Sandy. It's really pleasure to see you after some time and to hear.
I know it's been a long time.
It's been a
Yeah.
long
Thank you so
time.
much.
Well, thank you for the
Thank you very
invitation.
much, and thank
I'll
you,
apologize.
everyone. Let's express our appreciation. I know we can't clap in the usual way, but I think it's amazing to have Sandy here, and we really thank him for joining us.
My pleasure. My pleasure.